So today I'm going to discuss the round robin algorithm and CPU scheduling. So here we have the given example. So we have process A, B, C, and D. And their arrival time of 0, 1, 2, 3, and their burst time of 5, 3, 8, and 6. And here we have a time slice of 3. So round robin is just a version of first come first serve, but round robin is an preemptive algorithm, meaning that it can be stopped. It can the processes that are being executed can be stopped if there are processes that have been encountered. So now let's proceed to the algorithm. So I've just put the A, B, C, D already so that there will be no time to waste. So now let's start the process. So here we have A in the 0, B in the 1, C in the 2, and D in the 3. So as you can see here, we've we've put the process based on their arrival time. So now let's start the process. So A has an burst time of 5. So since we only have a time slice of 3, so we are going to only count to 3. So let's start from 0, 1, 2, and 3. So A will be putted in the ready queue. So after, rad- not really after. So during the process of A, we've encountered and B, C, and D. So B, C, and D will be putted in the ready queue, and A will be putted in the CPU. But since there are two remaining burst time left, A will go back to the ready queue. But after the process D, since D comes first before A. Now let's proceed to letter B. I mean process B rather. So here we have B that has a burst time of 3. So since our time slice is 3, we're just going to execute the whole process of B. So let's just count 1, 2, and 3. So it will go to 6. So now B will be erased in the ready queue and will be putted in the CPU. Now let us proceed to the process C. So C has a burst time of 8. So since our time slice is only 3, we are just going only to count 3. 1, 2, and 3. So C will only be executed up to 9. C will be removed in ready queue and will be put in CPU. But since there are burst time left in the process C, which is 5, process C will go back to the ready queue after the process A. Now, now let's proceed to process D. So here process D has a burst time of 6. So let's just put burst time 6. So we have a time slice of 3. So we're just going to count 3. 1, 2, 3. D. So D will be removed in the ready queue and will be put in the CPU. But since there are 3 burst time left, D will be going back to the ready queue after the process C. So now, let's proceed to the remaining burst time of the process A. So here we have a burst time of 2 of the process A. So since our time size is 3 and our burst time left is only 2, so we're just going to put all of them. So let's just count the burst time of A. 1, 2, A. And now A will be removed in the ready queue and will be put in the CPU. Next is process C. So here process C has a remaining burst time of 5. So since our time slice is only 3, we're just only going to count to 3. 1, 2, 3. Go to 17. Process C will be removed at the ready queue and will be put in the CPU. But since there are remaining 2 burst time left, C will be going back to the ready queue after the process D. So now let's proceed to the process D. So here process D has only 3 remaining burst time left, so we're just going to execute them all. So let's just count 1, 2, 3. D. There you have it. D will be removed at the ready queue and will be put in the CPU. And lastly is process C. So since process C has only 2 remaining burst time left, we will execute all of them. 1, 2, and there you have it. C will be removed at ready queue and it will be put in the CPU. Now let's solve the waiting time of the round robin. So the technique here is simple. So first, let's just write down the arrival time of all the process. So 0, 1, 2, 3 on both waiting time and turnaround time. 0, 1, 2, and 3. Now, first is the waiting time. So here we have the waiting time of A. So to find the waiting time of A, let's just label this to for us to easy to find what are their waiting time and turnaround time. 6, 9, 12, 14, 17, 20, and 22. So the waiting time is it's the time where the process waits. So here, to put it simple, the waiting time is where the process is not yet executed. So here, Our waiting time of A is 0. 0. Take note, all of them are going to use minus or the difference operation. There. Next is the B. So here 3 is the time that it is not yet executed. C is 6 and D is 9. So now here we have another one which is A. So A has a second time of execution. So to solve that, let's just put a parenthesis and add now to identify what will be putted in the second parenthesis. So just look at the second time of execution of the process. So here in A, the it's waiting no rather it's waiting time in the second execution is 12. So we're just going to put 12 here. And now we're going to minus it to the time that the process A has ended in the first execution, which is 3. So there. And there you have it. So since B has no second time execution, we're just going to equal it C. Now C is quite a long solution because it has three executions. So we're just going to put it in a parenthesis and plus. So let's just look at the second execution. So the its waiting time is 14. So let's put 14 here. And let's just look at the first execution rather, and the time that it has ended in the first execution, which is 9. Plus next is the third execution, which is 20 minus 17 equals, and lastly is D. So here just repeat the same process, 17 and 12. And now let's solve it. So 0 minus 0 is 0, 12 minus 3 is 9. So 0 plus 9 is 9. 3 minus 1 is 2. 6 minus 2 is 4. Plus 14 minus 9, 5. So 4 plus 5 is 9. Plus 20 minus 17 is 3. So 9 plus 3 is 12. And lastly is D. Mine 9 minus 3 is 6 plus 17 minus 12. So 6 plus 5 is 11. And let's just add it together. So 9 plus 2 plus 12 plus 11. So 9 plus 2 is 11. Plus 12 is 23. Plus 11 is 34. So now let's proceed to the turnaround time of the round robin algorithm. So the turnaround time is just the computation of the process in which it has ended. So first is the turnaround time of A. So here we're just going to look for the time that the process A ended. So here in the given, process A ended at 14. So we're going to put 14. Here in B, it has ended at 6. So we're going to put 6. In C, it has ended at 22. So we're going to put 22. And lastly is D, in which it has ended at 20. So we're going to put 20. And now let's compute. 14 minus 0 is 14. 6 minus 1 is 5. 22 minus 2 is 20. 20 minus 3 is 17. And let's just add them. 14 plus 5 is 19. 19 plus 20 is 39. And 39 plus 17 is 56. And there you have it. That's how you use round robin algorithm in CPU scheduling. That's all. Thank you.